Hi everyone, I am Prachi Agarwal. Welcome to our channel Learn Competitive Programming with CodeChef. If you are interested in competitive programming and want to learn and master data structures and algorithms, then this is a one-stop destination for you. Every week we post CodeChef problem explanations, conceptual videos on various programming paradigms, and also conduct live problem-solving sessions. But before we actually get started, here's a reminder to hit the subscribe button if you haven't yet already. Great! Now that you have subscribed, let's get started. Today we'll be solving the problem 3 letters, which is a simple problem and it belongs to the December lunchtime. Now let us see the agenda for today. First, we will try to understand the problem statement. Then we will see how we can reach to the solution of the problem. We'll see a short summary of the solution that we have discussed, and then we'll do a quick walkthrough of the code. But before we actually get started, I have some great news to share with you. Did you know that CodeChef also conducts free live classes on Unacademy where we teach every possible topic related to competitive programming? We have beginner level courses like Introduction to C++ and Java, basic data structures. We also have advanced level courses like greedy problems, recursion, and advanced data structures, problems on graphs and trees. These courses are taught by the top coding experts who are IOI medalists, ICPC World finalists, and have worked in top product-based companies like Apple, Microsoft, Google, LinkedIn, Flipkart, and so on. So all you need to do is download the Unacademy app or register yourself on unacademy.com and choose your goal as competitive programming. You can also take the paid plus subscription to get additional benefits and individual level support. We have a large set of practice problems associated with every topic related to competitive programming. Also, we have 6-star and 7-star teaching assistants who will take up your doubts during the session and after the live session. So, you can use my referral code to subscribe to Unacademy. Use Prachi16 as the referral code and get 10% instant discount. So what are you waiting for? Hurry and start your competitive coding journey today. So in this problem, we are given a string S and we can obtain some coins by performing some operations on the string. So now what is that operation? We have to choose 3 characters from the string, and if those chosen 3 characters can form a palindromic word by arranging them in any order. So the order is not necessary that whatever order it was present in the string, in that order only we have to form a word. No. We can choose any 3 characters. Say we are choosing C, then we are choosing D from the string, and we are again choosing C. And after choosing these 3 characters, we have to see that if we can form a palindrome word out of these 3 characters. So is this possible here? Yes, CDC, this is forming a palindrome word. In this case, we will remove these 3 characters from the string, and for every such operation, we will get 1 coin. Now, in this operation, we are removing these 3 characters. That means the length of the string is reducing, and this operation can be performed repeatedly until there are no other characters left in the string, or it is not possible to form these palindrome words out of the characters that are left in the string. So we have to find out at last that how many maximum number of coins we can obtain by performing these operations repeatedly on the string. So guys, the point to note here is that each time we are reducing the length of the string by choosing 3 characters and removing them if they are forming a palindrome word. So how many such words will be possible out of any given string? So if the length of the string is n, which is in this case 13. So if the length of any string is n, then there will be n by 3 such divisions possible. What do I mean by divisions? That is that each time we are selecting 3 characters, and if they are forming a palindrome word, then we are removing those 3 characters. So we are dividing the string into groups of 3 characters each. So how many such groups can be formed? It will always be n divided by 3. So in this case, there are the length of the string is 13. So how many 3-lettered words are possible in this string? There are 4 3-lettered words possible. And we are taking the floor value of this operation. That means we are taking the floor value of n divided by 3 because we need exactly 3-lettered words. It is not possible that there can be less than 3 words, then also it is fine. No, right? We need exactly 3 letters every time. So here, as you can see that if your length of the string would have been 12, then it would have been 12 is divisible by 3. It means no problem. We can directly say that there will be 4 3-lettered words. But since here the length of the string is 13, that means we have one extra character. But even if we have one extra character, it will not be able to form a 3-lettered word because it is a single character. So that is why we will always take the floor value of this division. Since now we know the number of 3-lettered words possible out of any given string, and also this is the criteria of obtaining the coins in our condition, that we have to form these 3-lettered words, and if this word is a palindrome, then we are supposed to remove these 3 characters from the string. That means that each character in the string will contribute only once to forming a palindromic word. That is why we can always say that these are the maximum number of coins that are obtainable. This value can never be more than n divided by 3 because there will never be more than those 3-lettered words possible out of a given string. So if all the 3-lettered words that we are forming out of the string are giving us a palindrome, then well and good. This will be our answer, that is n divided by 3. In the case when all the 3-lettered words that are formed were palindromes. But it is not always necessary that a string can give us all the 3-lettered words as palindrome. It is not necessary, right? So in that case, what we are supposed to do? Let us try to observe the properties of the 3-lettered palindrome that we will be forming. So let us choose 3 characters out of this string. Let us choose C, O and C. This is a palindrome word, right? Out of the chosen characters, we were able to form a palindrome by arranging it in this manner. Now, what can you observe in this palindrome word? You can see that the first character and the third character are the same, and the middle character can be anything. Even if we choose, suppose F here, instead of O, if we place an F here, it will still remain a palindrome. If we place any other character, that is R here, then in that case also it will remain a palindrome. So for a minute, let's ignore this middle character because this character can be anything. But we are concerned with the first and third character, which has to be same, only then a palindrome will be formed. So what we can say, that if the frequency of any character in the string is 2 or more than that, only then it will be eligible to form a palindrome. Otherwise not, right? If it is a single character, that is if it is an F, suppose in this string if you choose F, then this cannot explicitly form a palindrome because it is a single character, and we cannot form a palindrome by using a single character. We need at least 2 characters because we want to satisfy this condition that the first and the last character in a 3-lettered word should be same. So what we can do is that we can find the number of pairs of same characters possible out of this given string, ignoring the middle character for a moment. So those number of pairs that we are finding out will give us the exact number of how many palindromes will be possible out of a given string. So in order to do that, what we will be required to do is that we have to calculate the frequency of each character given in the string. So as you can see that I have already calculated the frequency of each of the characters that are present in our string. Now we will have to decide that all of these characters will be able to form how many pairs which have the same characters in it. So a pair consists of 2 characters, right? So that is why we will have to divide the frequency of each character by 2, which will give us the number of pair of same characters which can be formed for each character. So like for C here, the frequency is 3. So that means there are 3 divided by 2 possible pairs of same characters. Here 3 divided by 2 will be 1. And we will take the floor value because we need exact pair. Again, the same condition is being applied here, that if we have 3 C's, then definitely only one pair will be possible, right? And this single C will be left out, which will not be able to form a pair. So likewise, we can fill up this entire table. This value that we have filled up by dividing the frequency of each character by 2, this tells us the number of possible palindromes ignoring the middle character. That is, this table is denoting the number of pair of same characters that can be formed. So let's denote this value by P, and if we sum this entire table, this entire column of pairs, then we will get the total number of pairs that can be formed of the same characters. So here it is P equals to 3. That means 3 pair of same characters can be formed, or you can say that are possible for this given string. Now these 3 pairs which are possible does not ensure that they will definitely be able to form a palindrome, because we have ignored the middle character. We do not know that for each of the 3 pairs we will be able to find out the middle character or not. So here in each pair we have 2 characters, right? So that means that for 3 pairs we are taking 3 into 2 equals to 6 characters from the string. But as you can see that our string is of 13 length. So that means 7 characters of the string are still left which are not contributing in forming a pair. So out of these 7 characters, for each pair we will be able to choose 1 character each, that is the middle character. This is the scenario that we have here, that C can form 1 pair, O is forming 1 pair and D is forming 1 pair, and we have the missing middle character for each of these palindrome words that we are trying to form. Out of these 7 characters, we will choose any character from the string and place it here, and these 3 palindromes will definitely be formed. And we also know the upper bound to this problem already. We know that the maximum obtainable coins, or the maximum number of 3-lettered words that were possible for this string were 4. That is x equals to n divided by 3, where n is the length of the string. Now out of those 4 3-lettered words, what we have established here is that out of those 4 3-lettered words, only 3 of them will be forming a palindrome. The 4th 3-lettered word will not be possible to form a palindrome. So that is why here the answer will be 3. But what if our P is greater than x, which means that we have more number of pairs of same characters? That means we can form more number of palindromes than the maximum 3-lettered words that are possible for a given string. What will happen in that case? So if we change our frequency array a bit, so you can see here that the total length of the string still remains 13. If you add the frequency of all the characters, then you will still get 13. So I have not changed the length. That means the maximum possible number of 3-lettered words that can be formed from this string will still remain 4. Here, as you can observe, that the possible number of pairs of same characters are more here, that is P equals to 5. Last time it was P equals to 3, but this time we are saying that we can form 5 pair of same characters. That means 5 palindrome words are possible if for all those 5 palindrome words we can find the middle character out of the given string. But guys, we already know that for this string there are only 4 3-lettered words possible. So you already know that there will never be 5 3-lettered words possible in any case, because the string length is not changed here. The string length still remains 13, and 13 divided by 3, we will only be able to form 4 3-lettered words. That means 4 palindromes at most can be possible for this given string. And here what we are saying is that there are 5 possibilities of palindromes that are possible if we can find out the middle character for each of the palindromes, which can be any character from the given string. So it means that the maximum number of 3-lettered words or maximum palindromes that were possible for this given string, which is 4, will in any case be possible, because we are saying that more than that can also be possible if the length of the string would have been more and we had more characters to place in the middle. What we can say is that if our p is greater than x, which means that the number of possibilities of palindromes are greater than the maximum number of 3-lettered words that can be formed, then in that case always our answer will be x, because x is the upper bound, which means that only those many number of 3-lettered words can be possible from the given string. So we will be able to obtain at most those many coins. It can never exceed that value. So our answer can never be p. And in any case, we will not be able to find out the middle characters for each of the palindromes here. But if our p is less than x, which means that the number of palindromes, the number of possibilities of palindromes are less than the maximum number of 3-lettered words that can be formed, then we will have to give importance to p first, because we are saying that out of the possible 3-lettered words, we can form only these many p number of palindromes, which is less than x. So that means that our answer should be p. That is, we will be able to obtain only p number of coins. So essentially what it means is that our answer will be minimum of p comma x. Whatever will be minimum, that many number of coins we will be able to obtain by performing the operations on the string that we have discussed. Now that we have discussed the solution to the entire problem, let us discuss a quick summary so that you will be able to reiterate the steps that we did in order to reach to our solution. So the first step was that we will calculate the number of possible 3-lettered words for any given string. So that we can do by taking the floor value of n divided by 3, where n is the length of the string, and that we will denote by x. Now what we have to do is that we will count the number of occurrences of each character in the string. That is, we will have to find out the frequency of each character that is present in the string. This step is important because we need to find out that how many pair of same characters are possible. So now the third step will be to count the number of pair of same characters possible. This will denote the number of possibilities of palindromes that are possible when we are ignoring the middle character of the palindrome. So this we will denote by p, and then our answer will be minimum of x or p. Because if x is less than p, it means that the number of possible 3-lettered words out of a given string is less than the number of possibilities of palindromes by ignoring the middle character. So it means that if we can form p palindromes, if we are establishing that, it means that we can definitely form x palindromes because x is less than p. So that is, in that case, x will be our answer. But if our x is greater than p, it means that we can form lesser palindromes than the number of 3-lettered words possible for a given string. So in that case, we will have to give importance to p, and p will be our answer. So I hope guys the problem is clear to you. Now let us have a quick look at the code which will be in Python. So guys, now let us code the problem in Python. First, what we have done is taken the input for the number of test cases, and for each test case we have taken input for the string on which we will be performing our operations. Now the first step in our problem was that we have to calculate the number of 3-lettered words that can be formed out of any given string. So that will be by dividing the length of the string by 3, and we have to take the floor value, so we will use the floor division operator of Python here. After that, the next step was to calculate the occurrences of each character in the string. For that, I will be using a dictionary in Python. You can also form a like frequency array, or you can use map, which is available in other programming languages. And similarly in Python we have dictionary, so I'll be using a dictionary here. Now I'll iterate through each character of the string and count the occurrences of each character present in the string and store it in the dictionary. So we'll check first that if s of I is already present in the dictionary, that is its first occurrence has already been added to the dictionary, then in that case we will just have to increment its value by 1. So f of s of I plus equals to 1. We have incremented the count of or the occurrence of that character by 1. Else, if it is a new character, then what we will have to do, then again f of s of I, this will add this character as a new key in your dictionary, and we will do equal to 1. So it will give the value to that character as 1, that is the first occurrence of that character. Now after forming this dictionary, we will have to iterate through the values of this dictionary, which will give us the number of pair of same characters, or the number of possibilities of palindromes that a string can have, and that we were denoting by capital P in our problem. So let us find that out for I in f dot values. So you have a function in Python to directly access the values of the dictionary, which is f dot values. So now we have access to the values of the dictionary, which will be stored in I each time for each character or for each key. Now that we have access to the occurrences of each character, so now what we'll have to do is we will add it in P, that is I divided by 2. What is this I divided by 2? It is telling us the number of possible pair of same characters, and this we will keep adding in P. So we will get the total number of possibilities of palindromes that can be formed. Now after this, what we'll simply have to do is find out our answer, which will be minimum of x comma p. And finally, we are going to print our answer. So now let us submit and see if we are getting the correct answer or not. So as you can see guys, that we have obtained the correct answer. So if you understood the concept, then please like our video and subscribe to our channel. And also guys, make it a practice to submit the problem even after the contest is over, so that it can enhance your coding practice. Also, in case of any doubts or feedbacks, please post it in the comment section and we'll be happy to help you.